Hello.
Yes. Yeah. Getting the voice. Yes.
Yeah.
Yeah, yeah.
So what I was discussing about that, the importance of Kubernetes in the software industry, right? So if I'll talk about Kubernetes, before that we need to understand what is Docker and what is containerization and what is container. Okay. So container is something like the runtime instance of your application, right? So all those container will have the independent role to launch an application, to make a service connection, right? So that is container. How we'll create a container? We'll create the container by using Docker. Docker is a tool, containerization tool, right? So it will create a compatible and very lightweight Docker file. From that Docker file, we'll create a Docker image, and from that Docker image, it is going to create a live application which is going to be like container. Okay, so Kubernetes, why it came into picture, that we need to manage multi number of containers. So in that case, if you use Docker as the containerization tool, so you have to do so many things by using manual intervention. Okay, if you need to uh, upscale your replicas from 2 to 3, I mean the number of container you need to increase or decrease according to load. So it was not that easy task in the Docker. So that's why to overcome all those issues in the Docker, we move into Kubernetes. So Kubernetes will have the self capability of healing and maintaining the cluster itself, right? So we'll discuss everything. What is pod, container, and all those things. So before that, I want to give you more context on Kubernetes. So it is a orchestration platform. That means the managing the container. Okay, we can replicate. We can like make it down the count of replicas of container. Okay, that management of that container we are going to name is that orchestration, right? So as it is doing orchestration, so it is the orchestration platform, and to manage the container, because container is not a permanent, it is ephemeral. I mean, it can delete every time, anytime. Okay, to manage all those container and to retain those data, so Kubernetes is used. And Kubernetes first release version was v1.12 for something in the year of 2015. And it is free and open source, everybody can use. Okay, so if I'll talk about the Kubernetes architecture, is it clearly visible to everyone, my screen, the architecture screen, right?
Yeah, visible.
Yeah. So you can see something is like worker node 1, worker node 2, and this is called like you can see CLI and UI. That means Kubernetes is divided into two parts. One is master node and another is worker node. So worker node, why multiple worker node is required? Why multiple master node is required? So master is something that which is going to manage all those Kubernetes operation. Okay, so it will have like some component called API server, scheduler, control manager, and etc. In today's scenario, you can take multiple masters, because for the high availability only, the master choosing a master maybe 1 3 5, so it will be on the recommendation of Kubernetes officer. You always have to take a odd number of master count. Okay, so that here you can see in this architecture we have taken one master. Okay, and the master have the component of API server, scheduler, control manager, and etcd. And also in this architecture you can see worker node 1 and worker node 2. So if I'll talk about the component of worker node, you can see pod 1, pod 2, pod 3, and kubelet, kubeproxy, and container runtime. So you'll think, what is container runtime? So previously we are creating the container by using Docker. Okay, so Kubernetes will work on top of that Docker. I mean, you can take any containerization tool. There is containerd, there is Podman, there is Creo, there is Docker. Okay, so you can choose any container runtime. So that will give you the option to make a container. But after creation of the container, it will have the complete control of Kubernetes to manage all those container. Okay, so if I'll talk about all those parameter like name, API server, scheduler, control manager, so you can see the UI means user interface, or CLI means command line interface. So in our previous session we are discussing about kubectl, although that was not due to some configuration issue, we are not able to communicate with our API server. If you use Kubernetes dashboard, in that case, you'll have some dashboard to communicate with your API server. Okay, so API server is the front end of the Kubernetes. Okay, whatever the command or instruction you will provide to the Kubernetes to execute some operation. Okay, so in that case, it will take the traffic from outside to the API server, and the API server will act as a front end. Okay, and then it will process the request and will generate the output by discussing with the another component. So once I'll discuss all those component, I'll give you the flow, how the flow comes from outside to inside, how the traffic flows. Okay, so for now you can understand API server is the front end. It can take the respect from GLI, I mean UI, user interface, or else CLI, I mean command line interface by using kubectl. Okay, then are you saying something? There is some noise in background.
Is video going on? Audio? Okay, I think somebody's okay, yeah, continue.
Okay, that's fine. I was discussing about API server. So API server will act as a front end. If I talk about scheduler, so schedule is something that it is going to schedule. Okay, so what it will schedule? So it will schedule the pod. Okay, whatever instruction the API server will receive, all those process will executed by the scheduler. Okay, if I have provided instruction to create a container for the Nginx. Okay, so the instruction will come to the API server, then it will processed by the scheduler, and then scheduler is going to schedule that pod in the worker node. Okay, so worker node, that means all those application, whatever application we are going to launch, maybe Nginx, maybe Apache, or maybe any application. Okay, so that application will schedule on any one of the worker node. Okay, it is not going to install on the master node, because master node has the sufficient resources to process only the managing all those Kubernetes resources. So all this application is going to schedule on worker node. So that is the role of scheduler. It is going to select the worker node and then schedule it. Okay. Then if I'll talk about the control manager, suppose that scheduler schedules some of the pod, I mean 3 pod, it has been scheduled. After that, what it will maintain the control manager? The control manager have the permission and the role, I mean responsibility, you can say. It will always have a plan to maintain all those pods. Suppose that I have created 3 pod, there may be some issue with this node, worker node. So pod got crashed. So then what the control manager will do? Control manager will discuss with kubelet. I'll discuss what is kubelet. Okay, and then information from the kubelet, that control manager will receive that this node is not healthy. Then what will does? It will schedule all those pod in the different worker node. That means the managing the pod, I mean if one worker node is not healthy, it is going to replace those exact pod in the another worker node. So it has the flexibility to manage all those pods, and it will decide whether and where the pod is going to schedule. Okay, and another component is etcd. Etcd, you can see etcd is something like called database, and the database is in the form of key value pair. Okay, so in the YML format, there is the database inside of that master node. You will get some specified directory, will have some etcd directory. Under that, all those information, because there should have some memory, there should be someone who is going to monitor, who is going to take all those data's backups. That means etcd will take all those backups. Okay, all those runtime information, what is the instruction that we have provided, what the process has been completed, and what is the error that is coming, how we can able to see those errors, because from this etcd stores all the runtime information. Okay, from the etcd we are able to fetch all those events from the resources, or events from the pod or deployment or application, right? So let's talk about worker node component. The worker node is something where you can schedule the pod. So if you'll see in the pod, you can create multiple container. Okay, as per my deployment, you can define how many containers should be scheduled inside of pod. So pod can contain a single container, or else more than 2 or 3 container, right? So multiple container you can schedule inside of a pod. So pod is very ephemeral. That means it can die at any times. Okay, but the beauty of that, if the pod one die, you no need to worry, because scheduler and control manager will schedule those pod in the different worker node. That means your application will be always on live. Okay, that is the beauty of pod, and that is the container. Okay, and if I'll talk about container runtime, as I was discussing about, Docker. Okay, Docker is the containerization platform. Similarly, Pod and Creo is also containerization platform. By using this daemon, I mean Docker daemon or Podman daemon or container D, we are creating those containers. Okay, that should be installed on the worker node, because all those installation process we need to execute some of the scripts, or else we have the manual steps to install container. We have the manual steps for kubelet, kubeproxy. There are so many ways we can install the Kubernetes. Okay, by using Terraform, by using Kubedium, by using Minikube. Okay, but to manage Kubernetes, all those information is required in the worker as well as the master. Okay, and another component is kubelet. Kubelet is something that it will provide the health information. I mean, this worker node is healthy or not. So what is healthy or what is not healthy? So if the worker node is having suppose that 4 GB of memory and 2 core CPU. Okay, and all those resource has been occupied by the spots. That means there is no space left in this node. Okay, how the information will be conveyed to the master node? So all those runtime information, I mean health of that worker node, will be identified by using kubelet. Okay, kubelet will provide this information to the master node. Okay, by using the kubelet, will get the health of that worker node. And then if I'll talk about the kube proxy, so kube proxy will be responsible for the networking purpose. Okay, the pod to pod communication, I mean container to container communication, from this worker node to another worker node pod communication. That means the application communication will be responsible by using the kube proxy, using the network. There is something called CNI, container network interface. So the kube proxy we need to configure with the CNI plugin. Okay, that also is the part of like Kubernetes installation. So once it is done, you will able to communicate with the one pod to another pod. Is that clear for the Kubernetes architecture, or do you guys have any doubt so that we can discuss before moving forward?
Yeah, I think we are good. Anyone else?
We encourage everybody to ask and speak, because that may be like new for you or may not be new for you. If we'll discuss, it will be a good interactive session so that we all can enjoy.
It's clear
Once more.
for me.
Yeah, yes.
Yeah, you can go ahead.
It is same for, there is some comment. It is same for node manager in Hadoop. Can you respond back
Manager,
to?
actually, he's saying, Dinesh is saying,
Yeah.
see, in the Hadoop architecture, YARN architecture, there is a resource manager and node manager. So resource manager is a master and node manager is a slave, and that is the type of task tracker who is doing the task. So so he's saying like node manager in Hadoop, right? It's the same as he's asking, right? So worker node, right? Pod is the same as the node manager in Hadoop, like it's like a pod is not like a doing task, right? Pod is not doing task, right? Who's performing the task, Niranjan? Pod is
Yeah.
basically a like container, right? Pod is having multi-container or single container, right?
See, pod is something that you can consider the room. Okay, inside of that room there are multiple people, so the people have the individual role. Okay, but here the people inside of that room will not directly communicate with the another room. Okay, so they will communicate by using the pod. That means pod has the like boundary. Okay, in that boundary, so you'll have the network configuration. Okay, so direct container will not disclose or expose to the another container. By using pod, it is going to expose. That means the actual application inside of the pod is running. Okay, and all those networking will be done by kube proxy. You no need to worry about how container one is going to communicate with the container two. All those will be application, maybe some specific process we want to execute, or maybe some like health check one container is required. So there may be the container is something that so many processes. That means the number of process you are gathering together, and you have assigned for a VM to execute. Okay, so in order to do that, in the containerization concept, we have implemented container. Okay, the multiple tasks you can do together. For that case, maybe we can use the like web application. Maybe we can use the container pod for the like database launch. Maybe you are using DB, okay, MongoDB or RDS. So in that case, what you are doing, you are taking one instance to install Postgres, okay. But if you use the Kubernetes to install RDS or no, sorry, Kubernetes to install Postgres. So in that case, the Postgres will work as a pod. That means inside of that pod, all those processes will happen. That means every process what you are doing in your individual VM or Ubuntu VM in anywhere, okay, that can be done by using pod. So pod will act as a like runtime environment, or it will provide a like isolation environment, okay. Inside of that you can do, and the networking will be done by proxy, and so many features we have like a service, ingress controller. By using, we can expose those services to outside. Somebody sitting in US, they can access my cluster, I'm in India, okay. So all those features we have. I think it's clear to the person that who has asked this question. Is that clear?
Yes.
Yeah, thanks. So that was like the overview of architecture. So you can see I have.
So one more
looked at the-
question: is it Kubernetes a cloud agnostic? That means if I AWS EKS, can I move everything to Azure? That's it, or it's going to be any
Yes,
setup needed?
yes. So Kubernetes is completely cloud agnostic, as well as you can also make it as air gap environment where no internet connection is working. There also you can install Kubernetes. Okay, that is the beauty. But for the air gapped environment, you need to work hard to make all those things in Tarball. Okay, from the Tarball you need to extract and execute those scripts. This is the another part. Okay, but it's possible, right? So let's move into the component that I have explained. You can see pod, container, kubelet, proxy. So if you have any doubt about those components, you can ask. We can discuss API server, scheduler, and something. Okay, I think it's clear to everyone. And this is all the note I have written, what is API server, etcd, and so on so. And Kubernetes component. That means this is the explain what is pod, what is container, what is Docker engine, what is kube proxy. You can see whatever I have explained, all those things, it is here same. Then if I'll talk about the component, these are the like component of Kubernetes architecture, okay. So if I'll talk about what and all services, what and all feature of the Kubernetes, you'll get it from here, right? So we have discussed the pod, okay. So pod is like the smallest building block that will create in Kubernetes to run our container, okay. So then if I'll talk about service, okay. So service is something this was like service, okay. So service is Kubernetes is an abstraction that defines the logical set of pods and policy to access them. This can be something through the load balancer or node pod or cluster. That means if you'll have discuss about service, that means service is of three types. One is cluster IP, one is node pod, and a load balancer. You might think, what is service? Service is something that Kubernetes component will give you the flexibility to access your application from outside of your cluster. So to access your application outside of the cluster from the browser, what you can use? You can use load balancer. Okay. I mean, you will have to provide the DNS entry. From that DNS entry, it will route the traffic to the service, and then service, it will route traffic to the pod. And inside of the pod, there will be container who is going to take the traffic. Okay. By using that, you will able to reach those applications. Or else you can use node port, or else you can use cluster IP. So when we are going to choose the node port, suppose that you are not using load balancer, you are just practicing for your purpose, okay. You don't want to take any load balancer, because load balancer you need to purchase, okay, the DNS and the certificate, all those things. You want to test your application whether it is I mean outside or not, accessible or not. So in that case, you can make the service type from a load balancer to node port, okay. So here you can see this is the service YML. Okay, so that will be another session how to write Kubernetes YML that we can explain. This is the syntax of in the YML format, and here you can see the cluster type is cluster IP. Okay, and the node port and load balancer. We need to choose after that port Okay, we can mention like the type. Okay, it is not provide me to edit. Okay, you need to provide the type and then you need to make as node port. Then only you can able to access the cluster by using your cluster IP and the node port. This is the target port we are targeting. Okay, by using the port and the node IP, we are able to access the cluster. Okay, and there is something called config map and secret. Okay, so you everybody knows what is variable and what is environment variable. In the Kubernetes world, we are not talking like what is variable, what is not variable, and how environment variable is configured. Here in Kubernetes, we are using the concept of config map. So all those non-sensitive information like username, okay, username you can consider as the config map, and the secret, that means the sensitive information, maybe some password, okay, database password, like this, and the certificate, those are the sensitive information. So on those things we can name as the secret, and all those non-sensitive information that we are using for the environment variable, we are using the config map. All those config map and secret, those are both are the environment variable in the Kubernetes, but the name is different because due to of the use case. I mean, it is sensitive, then it will come under the secrets. If it is not sensitive, then it will comes under the config map. I hope it's clear to everyone. Okay, so there is something called PV and PVC. That means persistence volume and persistence volume claim. Okay, in your pod, you can see, as I said, pod is not a like lifetime entity, so it will not have longer life. It can die at any time. So how you will retain those data? Suppose that you have some transaction with your bank, so that transaction details you need to capture. How you will capture all those things? So that is the concept of PB and PBC came into picture. That means, so PB and PBC will work together. It will configure with the network location. Okay, and suppose that here you can see I have used the storage class as standard, and the host path is here, and the type. Yeah. Here I'm using my local path. I mean, inside of my local VM, I'm going to provide. In the host path, you can also provide the S3 location or else the NFS location. That means whatever location that you want to prefer to provide here to store your data. Accordingly, it is going to use the PB and PBC. The Ingress. So as I was discussing about the load balancer, so Ingress will provide some of the option for the HTTPS and SSL termination. Okay, and it will work in layer 7 security protocol. Okay, so here that we have taken a domain, suppose that www.example.com, and we have the application with the suffix maybe Hadoop, maybe big data, or due to reason why we have explaining is that you can configure your application with any subpath. Okay, whatever code you have written accordingly, you can do the subpath here, and you can make the path as prefix, and you can provide the service. Whatever service that we have created using the load balancer, you can provide that service name, and the Ingress will reserve those HTTPS and SSL termination, as well as it will also work as the reverse proxy. I mean, it will define the rule. Okay, what will be your application domain name? Accordingly, it is going to reset. I mean, redirect the traffic. And there is something called daemon set. So daemon sum that if you want to schedule your pod in all of the worker node, that means you can change your YML to kind of daemon set, and you can provide those container name and the image. Okay, image means Docker image you have to provide. That means if I'll apply those daemon sets, so that means all those pod is going to schedule in every worker node. Suppose that you have 20 worker node, so it will going to schedule in all those. Okay, this is the feature of daemon set. Okay. So if I'll talk about replica set, so replica sets, the purpose is to maintain a stable set of replica pod. Suppose that if you want to make the replica count as 3, okay, so that's why it will come into picture. You need to provide the replicas number of replica, and that will work most likely the deployment. Okay, so if we discuss about the deployment, it is just like hierarchical part of the deployment. Okay, and similar the replication controller and replica set both are same. there is a little bit difference between replica set and replication control, which is set based selector and equality based selector. Okay. And this is all I think about the architecture. Okay. And I will ask Arvind sir to explain the Minikube architecture or Minikube installation so that everybody will take help from out of that.
Hi everyone.
Yeah.
Okay. So
I'm just stop
this
sharing.
Niranjan Minikube is not working. It's giving issue with this EKS we did. Okay, but okay, let me start the meeting.
Okay, we can stop recording. Okay, that session is good that we have conducted right now. So I'll do that later. We can do stop.